Okay, this is Business 271. This is Dr. Gilby. We're going to do some work on the PowerPoint slides for you. Uh, People have been emailing me saying what types of things should I need to know. If you'll look at the beginning of every PowerPoint slide, they'll have a list of things. Here we have data and statistics. Okay, definitely know what statistics is. Statistics can refer to numerical facts such as averages, medians, percentages, and maximums that help us understand a variety of business and economic situations. It can also refer to, and this is probably the more common definition, the art and science of collecting, analyzing, presenting, and interpreting data. Applications, these are things you can easily read in the book, but statistics is used in almost every field of business, from accounting, economics, finance, marketing, production, information systems, especially if you're working for a large corporation. You're going to have statistics every day in your life. You may not be asked to compute them, but you will need to have an understanding of statistics so that you can take the information given to you by statisticians and use it to make proper decisions in the business. Okay. Data and data sets. Data are the facts and figures collected, analyzed, and summarized for presentation and interpretation. If we were to do a study of all the students in this class, I might ask you, each and every one of you, what is your height? You all would give me your height, say in inches. That would be data. I've collected the data, then I would analyze it. I might add all of the heights together, divide it by the number of students in the class, come up with a mean or an average height for the class. I might find out which student is right in the middle and say 50% of students are taller than this, 50% of the students are shorter than this. That would be a median, excuse me. Or we might look for the most common height amongst students in the class. Say it was 5'10", that would be our mode. Then we also might calculate variance, standard deviations to see how much that data is spread out from that median, mean, or mode. Elements are the entities on which data are collected. A variable is a characteristic of interest for the elements. A variable is simply something that can take on a number of different values. Height in the class can take on different values. Some people could be shorter, some people could be taller. All of those different possible heights would be values that the variable height can take on. Okay. The set of measurements obtained for a particular element is called an observation. A data set with n elements contains n observations. So for our height example, if we had 25 students in the class, I would get everyone's height. My data set would have 25 elements. Okay. The total number of data values in a complete data set is the number of elements multiplied by the number of variables. Here we have some information on different companies, Dataram, Energy South, Keystone, Landcare, Psychmedics. We have the stock exchanges they're listed on, annual sales, and earnings per share. You can see where the data set is composed of. All of the headings here are variables, and that is a particular observation, say for Energy South. Scales of measurement. This is important, especially for the first quiz. We have nominal, ordinal, interval, and ratio level data. You must memorize what the definitions for each type so that you can know what type of data or scale of measurement you're using with your data set. The scale determines the amount of information contained in the data. Nominal scale, data are labels or names used to identify an attribute of the element. Nominal data is a non-numeric label or numeric code. So, for example, if we were looking at majors of students at a university, different non-numeric labels such as business, humanities, education, and so forth would be used. That's nominal scale data. Another example would be if we used numbers to denote those different majors. That would also be nominal data. The numbers here have no relationship to each other. One doesn't signify more or less than 2, 3, 4, etc. Ordinal scale data. The data have properties of nominal data, and the order or rank of the data is meaningful. This is important. a non-numeric label or numeric code may be used. This most common example of this would be standings, say in a baseball league, say the National League West. The Dodgers might be in first place. The Padres might be in second. The Diamondbacks in third, and the Giants in fourth. Those numbers, or the terms, first, second, third, and fourth, or 1, 2, 3, 4, those tell you the order. The Dodgers are the best team, the Padres are second best, so forth and so on. But what it does not tell you is how much better. The Dodgers could be a game ahead of the Padres or 50 games ahead of the Padres. It doesn't matter. They would still be in first, and as long as the Padres had the second best record, they would be in second. Interval scale data. The data have properties of ordinal data, and the interval between observations is expressed in terms of a fixed unit of measure. Interval data are always numeric. If you look here, they're using the SAT scores of Kevin and Melissa. Kevin has a 1880 score. Kevin has an 1880 score. Melissa has a 1985. Melissa scored 105 points more than Kevin, but that does not mean that, we can't put any meaning to that 105 points. Another example of interval scale data would be temperatures, degrees Fahrenheit. Ratio scale is what most people think of when they think of data. The data all have all the properties of interval data, and the ratio of two values is meaningful. Ratio data are always numerical. The zero value is included in the scale. Zero means an absence of that property. Dollar prices for a book are given in your PowerPoint slides here. The price of a book at a retail store is $200, while the same book sold online is $100. That would tell you, because it's ratio level data, that the price of the book at the retail store is two times the price of the online price. Ratio scale data has that zero is meaningful. If we go back to interval level data, in this case, zero does not mean an absence of the property, say 0 degrees Fahrenheit. That does not mean an absence of heat. So Fahrenheit would be on an interval scale. Dollars, in terms of price, would be on the ratio scale. Data can further be classified as being categorical or quantitative. Okay, and this is important. Categorical data are labels or names used to identify an attribute of each element. It's often referred to as qualitative data. We can use either the nominal or the ordinal scale of measurement. Can be either numeric or non-numeric. Appropriate statistical analysis are rather limited. It's important to know if you have categorical or qualitative data. With qualitative data, you can do fewer things to them from a statistical standpoint than you can quantitative data. Quantitative data indicates how many or how much. It's always numeric. Ordinary arithmetic operations are meaningful for quantitative data. Here we have everything broken down. We have data, categorical, quantitative. You'll also hear categorical referred to as qualitative. Categorical can be numeric. You can have nominal or ordinal data in that numeric category. It can be non-numeric, nominal, or ordinal. So for example, here, ordinal data, first place, second place, third place, fourth place in the National League West. Nominal data, blue eyes, red eyes, green eyes, blue eyes. Numeric, nominal data, 1, 2, 3, 4, 5 in a list of favorite, that would be here for ordinal, in a list of favorite flavors of ice cream. Chocolate is 1, vanilla is 2, strawberries 3. Numeric nominal would be where we have a number assigned to some arbitrary attributes such as a 1 for a business major, 2 for a humanities major in a science class in a university. Quantitative data, is always numeric, and it's either interval or ratio. The main difference between these two is one, interval level data. 0 is not meaningful. Ratio level data, 0 means an absence of the property. We have cross-sectional and time series data. Cross-sectional data are collected at the same or approximately the same point in time. Data detailing the number of building permits issued in November of 2013 in each of the counties of Ohio would be an example of cross-sectional data. If we were to go out and measure the speeds of all the cars on Rainbow Drive today, that would be cross-sectional data. Time series data are collected over several time periods. Okay, they say data detailing the number of building permits issued in Lucas County, Ohio, in each of the last 36 months. So we're going back in time and collecting this data over time. Here's a graph of time series data. This is the average price per gallon of gasoline here in the United States. You can see we go from January of 2009 to April of 2014 and even further. You can see that over time, the price of gasoline has changed. It's obviously gone up and gone down at different times. Data sources, there's numerous places you can get data. This is one of the things that statistics students come out with the least amount of knowledge of. You can get it from internal company records, mostly if you're working for that company. There are large business database services such as the Dow Jones and Company. Government agencies, U.S. Department of Labor keeps unemployment statistics. Industry associations, the Travel Industry Association of America, special internet organizations. Off the internet, more and more firms are placing their information on the internet. Another place you can get a lot of information is from the Federal Reserve Bank of the United States if you're looking for economic information. The FRED, Federal Reserve Board of St. Louis, keeps FRED, which is a database of economic data. There's some other sources there for you. Okay. You can also get it from statistical studies, observational. In observational, non-experimental studies, no attempt is made to control or influence the variables of interest. An example would be a survey. Study of smokers and non-smokers are observational studies because researchers do not determine or control who will smoke and who will not smoke. Experimental studies, the variable of interest is first identified, then one or more other variables can be identified and controlled so that the data can be obtained about how they influence the variable of interest. You would see this in a scientific study by the Public Health Service or in a laboratory. Okay, when we acquire data, it's very expensive. There's certain things we have to keep in mind. One is the time requirement. Searching for information can be time consuming. Information may no longer be useful by the time it is made available. The cost of acquisition. Organizations often charge for information even when it is not their primary business activity. Data errors. Using any data that happen to be available or required with little care can lead to misleading information and throw off your study. I'll stop this and we'll have video number 2, which will start with descriptive statistics.